Hello and welcome to the second video about placing buildings on parcels. So in the previous video we managed to prepare all of our parcels for the next step, and here I want to explain the algorithm behind this script and show you the very simple implementation of it without any parameterization and without any tweaks and improvements which we will cover a bit later in the next videos. So let me open the top view of the result, where I can explain you how it works. So this script basically takes all of the parcels which we generated on the previous step. So the similar parcel network is something we start building on top of, and we would also need to draw some reference buildings, like those two small buildings here. We will just start with one typology, and the script will try to take those buildings and place them on the parcel. So in this more advanced version of the script, we also select the topology based on the parcel size. So if the parcel size allows us to place a bigger typology, we take this one. If the parcel is too small, then we take the smaller typology. The building should be placed close to the front facing edge of the parcel. So the building should be pretty close to the closest street. And we basically want to place our building somewhere in the middle of this edge. So it should be almost in the center of parcel, but a bit closer to the street. And yeah, now I will explain you how it all works. I will probably start with a new file. Oh, sorry, not with the new file, but the file we had from the previous video, this one, which already includes all of the parcels. And now I want to show you how you place the buildings themselves. Okay, so I'm taking the outputs of our parcellation script, the second iteration. I immediately want to flatten it so that I don't have to cope with the data tree structure. And I'll just move it a bit to the right. So these are my parcels. Another input I would need will be my streets. So let me create the curve component, name it streets. And now I need to connect to something, right? So I need to find a place in my script where I have all of my streets saved. And I think the best thing I can use would be the city blocks output of this first iteration of my parcellation script, which we called minor streets the last time. So the city blocks, even though do not represent the clean street network, they still give us all the shapes, like all the lines where you can basically arrive on some vehicle or just by foot. So these are public streets. You can also take the offsetted version, it doesn't matter that much. Yeah, I think I will actually take this one. So I want to connect this offset curve to the streets. And then move it here to the very end of the script, where we will start to build the new group. I will use streets to identify which edges of these parcels are actually the closest to the streets, so that I can place building on these street-facing edges. And these are my two main inputs. Another input, which is quite important, would be the building itself. But let us maybe start with a simple rectangle. So I'll just create a small rectangle, or maybe, yeah, let's see how it goes. Maybe I will use it, maybe I will use the one which I draw in Rhino. Okay, so the first step of the algorithm is to identify edges of these parcels closest to the streets. To do this, I need to explode my parcels. And so now I end up having as a data tree of, in my case, 203 branches. Each branch corresponds to one parcel, and each branch has around 4, 5, or maybe 6 edges, depending on the shape of the parcel. Now, among those 4, 5, or 6 edges, I want to find the one which is the closest to one of the streets, to any of the streets. How can we do it? This might be a bit tricky to imagine this process in your head, just because Grasshopper will make your life a bit harder because of the data trees and different branching. But let us try to do it. So for each segment, let's just imagine I have one parcel for now, right? So let's just think of having one little parcel, and there is a street somewhere close to it. So when I break this parcel into segments, I end up having 4 segments, 4 edges. Now for each of this edge, I need to find the distance to the street. In our case, I just have one street. If I would try to find, what is the distance from an edge to the street? If you think about the smallest distance, so what is the smallest distance of an edge to the street, then for the closest edge, this will be this distance. And for the farthest edge, this will be this distance. But the problem arises when we try to compute the closest distance from side edges, because this is this closest distance, right? So if I'll just draw it separately. So the distance from this edge to the street will be this small segment here. And in our case, this is not what we want to measure, simply because we will end up having 3 edges having almost the same distance to the closest street, right? And we somehow need to identify the one which actually goes along the street. So let me remove those things and draw everything again. So what we want to have instead is not the closest distance of the edge to the street, but the distance between the center point of the edge to the street. Because in this case, look what happens. So the distance for this segment and this segment, they basically remain the same. But when we try to measure distance from centers of those segments to the street, you can clearly see how it becomes it becomes much longer than the distance from the closest edge, this one. And we are interested in finding this edge, so somehow we need to identify it very reliably. And so this is what we will do. So we will measure distance from every middle point of the segment towards the street. Right, so for those segments, I need to take the middle point now, curve middle. Okay, so these are my parcels, and this should be the middle point of all segments there. Okay, this is good. Now, the problem is that we don't have only one street, we have multiple. Let us do everything step by step, and for now, let us try to identify what is the distance to the closest street of each edge of each parcel. Right, so we don't solve the whole problem, we just try to come to the next step. What is the distance to the closest street of each edge? Now we have the data tree of 203 branches. Each of them has around 4, 5, 6 middle points. Right, so each branch represents each parcel, and inside we have multiple points. And as for the streets, we have a list of 32 polylines here. So now we somehow need to take each of those middle points and compute distance from each single of these points to all the streets and choose the smallest distance, the shortest distance. To do it, I will use the curve closest point component, which is a very reliable way of measuring the distance between point and a polyline. But as you probably can guess, I cannot simply connect points to points and streets to curves because I have different data tree structure. So here I have 203 branches and multiple elements inside each branch. And here I have multiple elements in one list. So to isolate this curve closest point operation for each single point among my middle points of parcel edges, I need to craft this data tree here to avoid having a situation where I have multiple elements in the same branch. So now I have a bit more complicated data tree structure, but all of my elements here are isolated in individual branches, which is what I actually want to have. So now I can connect it to the points, and streets I can connect to the curve input of the curve closest point. Now, if you check how curve closest point works and look at the structure of inputs, you'll notice that all of the points are in individual branches. So curve closest point will run isolated for each point. And for one point and one branch, it has the whole list of 32 streets in one list, right? So they're not stored in branches. So it means that the whole list will be used for every single branch, meaning for every single point of this P input. So the curve closest point will run many times, in my case to 26,000 times, and it will compute the distance from every point to every street. And it will pack it in the kind of mixture of input structures from those two inputs. So it will basically retain the structure of data tree having two levels of branching. So it will have the branches stored like 0, 202, 3, and then it will have 32 elements in each of these branches. Why 32? Because we have 32 streets to measure distance towards them. Now, among all of these distances inside each individual branch, we want to find the shortest one. We want to find the shortest distance to any street. To do this, I can sort the list. So I sort the list of distances. And from the sorted list, I take the first one. This will be the shortest distance. I can maybe connect a panel to check that my assumptions are correct and that I have a meaningful data tree containing some numbers. And these numbers are actually distance to the closest street in meters. And the data tree structure here is still retained the same. So we have the data tree of 0, 0, 0, 0, 0, 1, and this first 0 actually doesn't bear any meaningful meaning. So I can also simplify the output of list item to just get rid of the 0. And now I have 0, 0, 0, 1, 0, 2, 0, 3, and then it goes to 1, 0, meaning that from here the new branch has started, like the higher level branch has started, and now we're talking about the parcel of index 1. And those 4 numbers account for parcel with index 0. Now, I don't actually want this, let's say, 4 first numbers to be stored in individual branches because they all belong to the same parcel, right? Every parcel has multiple edges. Each edge has its middle point, and this middle point now has the shortest distance to the street. So I want to pack it all inside the same branch, which accounts for 1 parcel. To remove those last indexes of indices of this data tree, I can use the trim tree component, trim tree, which looks like somebody cutting branches from the tree. So if I simply connect my outputs of list item to the trim tree, I can check that the output data structure is actually exactly what I need. So this will be the data tree containing 203 branches, and it corresponds with number of parcels. And each branch has just values of the distances between its 4, 5, or 6 edges to the closest street. Okay, this is good. I think this was the hardest part of this video, and I hope you understood this one. If not, you can maybe try to connect panels to some intermediate steps of this script to understand it better and in your own pace. For now, I will just move forward. So again, I have parcels. Here I have my edges of the parcels, and here I now have distances of edges from edges to the streets. What I'm interested in is to find only one edge for each of the parcels, which is the closest to the street. So on this parcel number 0, I have these 4 distances, which are 0, 0, 68, and 41, meaning that I want to somehow get this this very first edge, or maybe the second edge, since it has exactly the same distance to the street, out of the list of all edges. For the second parcel, I would want to have edge number 1, since it has 0, and therefore the shortest distance towards the road. For number 2, I want to have one of those edges. For 3, I want to have one of those edges, and so on. And yeah, of course, sometimes 2 edges will have the same distance. It basically indicates that your parcel stands on the corner of the city block, and it has streets going from both sides of this parcel. And in this case, we don't actually, it doesn't matter which of these 2 edges we take. So to somehow come from these numbers to the edges themselves, I need to sort numbers first. So this is the second time we apply sort now, but for a bit different reason. So I want to sort these numbers, meaning that all of the zeros will come to the very top, and yeah, so the numbers will be sorted from smallest to highest. And at the same time, I'm not that interested in the numbers themselves. I want to get the edges. So it means that I want to sort my edges as well. And for this, I will go back to my explode component, take the segments, which is the same as edges in this case, and connect it to the second input of the sort list component. So now sort list will sort all the values from the first input, keys, and along the way it will also sort all the data items from the second input A. So it will sort them exactly identically as it will sort the keys here, which are the distances. And so since my distances are sorted ascending from zeros to higher numbers, it means that my edges are also sorted from shortest distance to longer distance. And if I take the list item now, which will give me the item number 0 from each of the branch, this is what I will end up having. So I will have 203 elements, 203 edges, 1 edge per 1 parcel, and this should be the closest edge to some of the streets. I can also check it by reviewing the streets, and you'll see that actually they even overlap, because for streets I was taking the offsetted streets, meaning that parcels probably like stand right on the same boundaries here. Okay, this is good. So I have 203 edges now, and now I only need to place buildings somewhere on these edges. Let us do it. So for this, I will use the component which is called um, wait, how was it called? It was, I think it was stored somewhere in transform, and it was called orient. Yes, of course. So the component called orient orients an object. Orientation is sometimes called a change basis transformation. It allows for a mapping of geometry from one axis system to another. And this description, I find it quite bad, and doesn't explain what it actually does in our case. But in simple forms, in simple words, orient component can take any geometry, let's say a cube, a sphere, a point, and it can move it from one place to another place. So from source plane to target plane. And it doesn't only move the object, it also rotates it. It aligns it together with the plane. And as you probably remember, each plane has some orientation, right? So in the origin point of my Rhino file, for instance, I have these two axes here, the green one and the red one. It's y and x axis. And they indicate some plane. So if I would like to move an object from this plane to some rotated plane, orient will also rotate it so that axis of this source plane will correspond with axis of the target plane. And as you probably already guessed, the geometry we will be using are those reference buildings, which I drew here in advance. You can also just draw them now. You don't have to have anything prepared here. So you can simply create a new rectangle in Rhino by typing rectangle and create a new rectangle. You can also enter numerical dimensions like 20 or maybe 25 by, let's say, 35 meters. So this is my reference house, and I will use it to place it on all of my parcels, which I have here, right? Now, let's try to actually do it. So let's try to to move and to spread this rectangle on all of the parcels. So to do it, I will need to reference it in Rhino, in Grasshopper. So I will create a new curve component, name it something like uh, building, maybe building rect, and I will reference it by setting one curve from this right-click menu. Now it is referenced. I can connect it to the G input of orient, and now I only need to define those source planes and target planes. As the source plane, for now we can just use maybe the center point of the building. I would use the area component for it. So I connect my building to the area to find this center point and connect the C output, which is the centroid, to the A input of orient, to the source plane. And yeah, since since Grasshopper is capable of converting points into planes on the fly, we don't have to create any plane here. But if you would see that if you convert a point to the plane yourself, you will see a small plane with two axes here, and this indicates the original plane. Now, what are my target planes? Target planes, I want to generate them from my parcels, and let us try to use those street-facing edges of the parcels. So these are currently lines, and let us try to convert them into planes. Actually, I don't know whether Rhino can do it or not. So I just connected my list item, which now contains many curves, line-like curves, to the plane, and let us check what we get. So instead of planes, I see some lines visualized in my Rhino window. It probably means that if I jump to the perspective window, I will see that those planes are actually indeed generated automatically from the lines which we had, but they are oriented vertically. So they are not XY planes, but X, yeah, I don't know. So they are also existing in the Z dimension. This is not exactly what I want. I want to generate the planes which will be situated in the center point of my edge, and I want axis of this plane to be facing, like one axis should face the edge direction, and the other one should be perpendicular to it, but still in XY plane. The easiest way to do it would be to use the frame. I think it's called horizontal frame. Get a horizontally aligned frame, read plane, along a curve at a specific parameter. So horizontal frame, I would need to connect it to the line, like to the lines or curves. So not the plane, you can remove the plane now. And as the t, I would need to enter some parameter on this edge. So normally, most of the curves and lines in Grasshopper will have parameter going from 0 to 1, but you can never be sure. And to actually be confident that you have the parameter going from 0 to 1, so that it makes it very easy to identify the middle point by typing 0.5 in this t input. I will type it right now. So to be confident that your curve has the parameter range from 0 to 1, you sometimes have to reparameterize it. So sometimes when you right click on the curve input or output of some components, you will have this reparameterize button. All it does is just feed the curve parameter range into this domain from 0 to 1. It doesn't change the curve itself. That's just changes the domain where you can evaluate this curve, meaning where you can get some point on this curve. So I have done it, and now I connect 0.5 to the t input to the parameter input, and you will indeed see that the horizontal frame gives me the planes. Each of them is situated on the center point of the edge. So this is exactly what I need, and I can now use it as my B input of orient component. Okay, let us check what happens now. So these are my parcels and these are my buildings. It all looks very promising. So you see that the buildings indeed got the orientation of the parcels, not the parcels, but the street-facing edges of the parcels. So they are actually placed almost correctly. Now the only thing which is missing is that buildings are not placed on the parcel itself, but instead they are placed on the street-facing edge. And it happens, of course, because orient component will move the original geometry, in our case the building, from plane A to plane B. And plane A, in our case, is the center point of the building. And plane B is the middle point of the street-facing edge, meaning that, yeah, Grasshopper did what it was asked to do, to move building on the right on the fence, right on the boundary of the parcel. This is not what we want to do. I want to place it a bit deeper on the parcel, and for this we need to adjust our source plane for the buildings. So we should find some other place, some other way to reference the source point. And instead of using the area component, I will do something better. I will create a new line in my Rhino close to the building. I will just draw the horizontal line for this case. And now I want to find the point on this line which is the closest to the center point of the building. So I want to find the point somewhere here, right before, because if you move the building from point here on this line to those frames on our parcel edges, it would basically mean that you move the building with the anchor on this reference line, and you move this anchor to the street-facing edge here. So the building must appear somewhere inside the parcel. Okay, so I would need to enter one more component, which is called curve closest point, where I will enter my reference street, because this is what it is. So this will be reference street. So I want to enter it as the curve, and as the point, I want to use the centroid of my building. So by doing it, I got this point, which is the point on the street closest to the center point of the building. And now I can use this point to orient my buildings. So I use it as the source plane. And if you check the results, I think they would look much better than before. Yes. So indeed, you can see that most of our buildings are indeed placed inside the parcel. And the cool thing about it is that if I move my building, my reference building or my reference street, the buildings on my parcels will also move. So you can see I can now really easily control the position of buildings just by moving this one reference building here. And for some cases, as you can see, buildings are placed outside of my parcels and not inside. The reason for it is that on some step here in our script, Grasshopper was not so sure how to count points of our parcels. Because let me illustrate it. If you have the parcel, which looks like this maybe, there are multiple ways of counting points here. You can count it like, well, let me start from 0. You can count it like 0, 1, 2, 3, 4, and 5 again, in the same point where we had a 0, just to close the polyline. So this will be going clockwise. But the other way would be, of course, to do it counterclockwise. So you can count like 0, 1, 2, 3, 4, and here 5. So this will go counterclockwise. And depending on how you store those points, which all make together this polyline, our plane orientation, when we take this horizontal frame of our edges, will also be flipped. So sometimes it will face, one of the axes will face outwards of the parcel, sometimes it will face inwards. There is this simple fix for this problem, and for this I would need to go back to my parcels before I exploded them into segments. And there is actually a way to flip all of my parcels and to orient them all in the same way. So that all parcels go counterclockwise, or maybe all of them go clockwise. To do it, I can use the flip curve component. It looks like this, flip curve. And I need to connect my curves to the C input. And so by default, the flip curve component will flip all of my curves, right? No matter which direction it was facing. So if I connect it to explode and check the outputs, this will be the result. So you see that some cases were solved by flipping the buildings inwards of the parcels, but on the all cases where we had nice results, now we have buggy shapes, right? Meaning that buildings are outside of our parcels. So to make it all consistent and to orient all curves the same way, we need to specify some guide to this flip curve. And the simplest guide could be the just one single closed curve. Important is that you use the same curve for all of inputs, for all of the curves. And in my case, I will just use the simple rectangle. I don't even care where it is created, but by default, rectangle is created somewhere here. in the origin point of my Rhino file. But again, I don't care about this rectangle that much. I just need to specify this guide for this flip curve so that it knows which direction all of my parcels should face. And now if I go to the orient component and turn on preview of my parcels, you'll actually see that it all looks very good and all of my buildings are placed inside the parcels, and this is exactly where I wanted to finish this video. So again, now we have these inputs: building, rectangle, and reference street. I don't need to have this plane anymore. Yeah, and the coolest part of the script is done by this orient component, which orients my reference buildings on all of the parcels here. And as you can see, the script itself is actually not that big. So please take your time to understand every single step of it. I will also share somewhere the Grasshopper file with more comments on each of the steps I'm doing here. And in the next video, I will try to improve some things in the script, make it more robust. I will also eliminate some edge cases like this one, where parcels are too small to place any building there, and so on and so on. So yeah, thank you for watching and see you in the next video.